It's easy and difficult to talk after so passionate speakers. And as you can see, I'm standing here as a representative of business with a tie and a suit. But believe me, I'm emotionally connected to what they say, and that there are many connection points. I'm working for a Dutch company. We don't make seats. But I'm Swiss. And when I look at Switzerland, we actually have some connection points, and I also have some connection points from my youth. While we have twice the size of Israel, I just checked it, and the same population, we also have 8 million people, actually the inhabitable area is only about 15%. The rest is mountains and lakes. So the density of population and the way how we have to take care of nature is the same. Now, we don't have a water problem anymore. We actually had one. You think that Switzerland made its money in the beginning with tourism, which is true. I remember we had some pictures from some rich Indians actually coming to Switzerland to enjoy nature at that time. Yeah, to leave money or deposit money there, yes. But when I was a child, I remember that the River Rhine had every day a different color in the city of Basel. There was no wastewater treatment in the 70s. And at that time, not to pollute became like what you had to do to stay in business. The industry had to pay to clean the water. Otherwise, the government said, we shut you down, even if they provided thousands of jobs in the city. I remember as a child going through the forest and picking up the plastic because people, my parents' time, they threw away the things. They didn't have the consciousness to actually not to pollute. What I want to say with that is, it's a mindset in the end, and things can be changed. So that's one connection point. Another connection point is sustainability. So let me see if I find my presentation in the end. So it's about sustainability. We talked about water pollution before, and I'm fully behind that. What I'm talking in the end is more waste pollution and how we link into that. To give you some numbers, there is a recent report from McKinsey who says that every ton of municipal solid waste which is not treated and collected causes the society $375. And it costs this the society because there are people sick, cattle is sick, we have a pollution of the ground, and that which means that the environmental or the farmers' production is much lower. And we see it in India, and I don't want to single out India. In whole Southeast Asia, as we'll see, it's the same problem. The waste is not properly treated and collected, and the solid waste will only grow. The more wealthier we get, the more waste we produce. So we need to come away from this kind of linear thinking. I produce something and throw it away. It's the same then with wastewater treatment. We need to start to recycle. Wastewater is a source of wealth if we do it in the right way. Waste is a source of wealth if we do it in the right way. And what we are doing as a Dutch company for Total Corbion, I introduce later on how we are set up, and what we are doing is linking into this and into solid waste. When we look at solid waste, we call it municipal solid waste, in 2012 we had globally 1.5 billion tons. I'm sorry I cannot make this full screen, somehow that's not working. And by 2025 we're going to have 2.5 billion tons of it. By 2050, it's going to be 3.8 billion tons globally. Now, right now, almost 50% of that is biomass. This biomass, in dumping in the land, together with the 10% plastic, causes two things. One is, we have, depending on where you look at, between 4 and 10% of the global greenhouse gases coming out of these waste dumps already by the methane. Which means we need to take the biomass out of it and treat it. The second thing is, and many of you have been probably aware of that, we have 150 million tons of plastic in the ocean, and every year we bring in another 8 to 10 million tons. this plastic now turns up in the food chain. We eat it. There are studies in Mumbai that every spoon of salt has 200 to 400 microparticles of plastic. There are studies which say the sand at the beach has 10% plastic. We don't know exactly what that does in our body. And there are people say, oh, it's harmless, and other people say it does great harm. But if it's too small, it will pass into our body, and it's carcinogenous in the end. It can change the DNA. By the way, I also have to tell you that I don't know whether the bioplastic which we produce is a solution to that. I think not. I think what we have to do is we have to take the plastic out of nature. It doesn't belong there. The reason why I'm concerned is that plastic generation is directly linked with urban life and with wealth. The wealthier we become, the more waste we generate. When we look at this graph, and it's a bit difficult to see, but I can share the presentation right later on. Here we have the waste per capita in kilogram per person per day, and over there we have the gross national income. The United States is up there. It's almost a straight line. India is down here. So if you want to become more wealthier, which you have a right to and everybody would like to, you will also generate more waste. So the problem is not going to get smaller, it's going to get bigger. Therefore, we better start now to do something about it. And bioplastics is one possible solution, not to the total problem, but of an aspect of it. The whole question of waste of this linear thinking basically came up with this. This is the report of the Ellen MacArthur Foundation, which was presented in 2016 at the World Economic Forum in Davos, which said, look, we have an 80 billion waste stream here where we pack food and other things one time and we throw it away. This doesn't make sense. It's an economic nonsense. We have a resource here which we could reuse. There are two advantages in bioplastics. What we do is we use sugar to make lactic acid. And lactic acid is what you have in your body. When you have a muscle ache, you have lactic acid. As engineers, you all know that. And we polymerize that and make polylactic acid. And you can see some samples behind there, what we can make out of it. They also have some in the presentation. So the advantage is that on one side you take carbon out of the atmosphere, so you reduce global warming. At the same side, it's biodegradable or compostable, so if you decompose it together with the food waste, if it's done in the right way, it also helps to solve the waste problem. And this is when we look into the European bioplastics, which is probably globally the strongest bioplastics association. This is the two benefits which they stress towards the European Parliament. So a quick introduction who we are. We are a joint venture between Total and Corbion. Corbion is globally the largest lactic acid producer, and Total, I think I don't need to introduce to you, they're one of the big energy giants, also making plastic, and they realize that some of the plastics will change. For example, polystyrene, they are the second biggest producer globally of polystyrene. That will start to disappear because of the fear that the raw material of polystyrene, the styrene, has a negative impact on the human being. Now we have a plant in Thailand, and we're just starting up. Corbion makes 120,000 tons of lactic acid there, and we make the lactide, which is nothing else than two lactic acid molecules together, and then the PLA. We need to do this because it's a polycondensation. As chemical engineers, you know that. Polycondensation under certain conditions, the forward-backward speed has the same speed, so you don't get to the required molecular weight. That's why you first have to make a lactide. That's how the factory looked a couple of months ago, and now we are in operation. And the reason why I'm here in the end, because we need partnerships. We need to build the value chain. So what this says is that we use sugar as a feedstock. Then we have Corbin making the lactic acid. We have we making the lactide and the PLA, but our responsibility of manufacturing stops there. But we work with partners throughout the value chain. So we are willing to help to give technical support for what's required afterwards, compounding, converting. We talk to brand owners, even the end of life. After the session here, I'm going to look at the biogas plant where we use the waste from a canteen, and we try together with our bioplastics, actually what we see there, we try to turn this into biogas and fertilizer. And that's what should happen. We should give the nutrients of the biomass in this municipal solid waste back to Mother Nature. That's where it should go. And there are studies which show very clearly that, yes, better water is important, but to bring these nutrients back onto the field is also very important. So what we need to do is for all the different applications, and yes, there is food packaging, but there is also fibers. There are packaging of other items. There is injection molded goods. There are many different value chains which need to be built here to make this happen. It's not very different, but there are some tricks you need to know. So let me give you a bit of an examples. I'm not showing everything here. Right now, the polylactic acid market is still relatively small. The global plastic market is somewhere at 350 million tons globally. PLA is about 160,000 tons. So that's less than 0. Whatever percent. It's very small still. The most of it is used in the single-use plastic, but the growth is between 15 and 20% of the bioplastic market. So it's clearly above average. The global plastic market until now was growing roughly with global GDP at 3 to 4%. Globally, the bioplastics market is growing much stronger or much faster. Biggest one right now in Europe is plastic bags, where the concept is I bring my fruits, my food home, I put my bio waste in the bag, and I give this to composting. So the bag itself needs to be compostable. That's the concept behind it. But we can also make yogurt cups, for example. Danone is already using several thousand tons of PLA to replace polystyrene. Why are they doing this? PLA is more expensive than polystyrene. They do this because they know at one moment polystyrene cannot be used anymore for food contact applications. And they want to be ready for this change. We can also make clear cups. They look like PET, but they're compostable. You have in Europe whole tournaments, like a tennis tournament or a soccer tournament, which are set up, and the whole waste, everything is collected and put into a composting plant. You're not allowed to bring any food in because of security reasons, so that's relatively easy to do. The only exception is PET bottles. PET bottles are separated separately and recycled. Another thing is we can make noodle cups and for hot applications. So the concept that you go out of the freezer directly into the microwave. This is in India still a bit far away, but in China, in Japan, in Korea, this is the norm. You have a lot of single households, 2 people who are working, they go into the convenience store in the evening, they grab something, they put it in the microwave, and then they throw the packaging away. The more urban, the more advanced India will become, this will happen in India as well. The problem is that in Japan, 20% of what's in the convenience store is not consumed, it's thrown away. It goes into incineration because the transportation system, which is very efficient to bring the things to the convenience stores, is not allowed to bring the waste back. It's not legally allowed to transport both in the same car. Coffee cups, these are vending cups in Europe. There are 20 billion of them used every year in Europe alone. We're now replacing them. These are trays, which you see you can use up to 135 degrees. There's also possible for agricultural application. We have heard that before. This is from in Thailand an example for rubber plantation. Thailand is the biggest rubber producer globally. They plant 90 million trees a year. Right now they pack it in bags. They cut these bags open with two effects. If they hit the root, when they move it from the nursery to the plantation, if they hit the root, the plant is dying. And these bags fly all over the place. This is a root trainer which degrades in a certain time, and you don't need to remove it, with the effect that you have less plants dying. And secondly, you can harvest a year earlier because the roots are deeper and 5 years longer. So even if this is much more expensive than a bag, it actually pays off. By the way, this is not 100% PLA. PLA in nature doesn't degrade fast enough. We needed to use other polymers here to make it happen. So when we look into end-of-life solutions, we see that every country and every region does this a bit different from a legislation point of view. And the good thing is in India, this is still very young, so India still have a chance to shape it the way you want to do it. But there are three driving forces. The US and China see it predominantly as an outlet for the agricultural surplus. So that's what the central government is doing. That's how bioplastics started in the US, is actually thinking how can we generate more value for the surplus crops we have from the farmers. The states in the US see it different. The coastal states, they want to stop global warming, because if global warming really comes to pass, the sea level is going to rise by 60 meters, 60 meters. That means Chennai, a lot of it is not existing anymore. The Netherlands is not existing anymore. And that's why we need to keep the temperatures below these 2 or better 1.5 degrees, and we're already at 1 degree. We really have to start to turn. And with the idiot in the White House, that's not so easy. The other states also look at it as helping, so look at bioplastics as either to reduce global warming or to help solve the problem with municipal solid waste. And you see the different countries have a different focus there. So PLA has a very good footprint. We see that compared with, this is the carbon footprint emissions compared to polystyrene PET. We only have 0.5 kilogram per kilogram of polymer. We will bring this down to 0 or close to 0 with the next technology. But polystyrene, for example, has 2.2. This is the carbohydrate usage for different bioplastics. So this is the beginning of life story. What we have to do in the end, and I can share, who everybody wants, I can share this presentation with you later on, there's no problem. What we need to do in the end is we need to sustainably create a circle. That's what we have to do. So we use the power of the sun to create sugar or starch. We do this anyhow, and you know that starch molecules is nothing else than sugar molecules glued together. So if you break them up, you go to sugar. So we can use both. We make lactide and PLA from that. We make our goods, we recycle as much as we can. So I'm fully behind, we recycle, we reuse, we prevent the usage in the first place if we can. If that's no longer possible, then we have to find an intelligent end-of-life solution for it. And we have to think from the beginning, what are we going to do in the end with it? This has to be built into our thinking. So like in the 70s, the river was polluted. Not to pollute became a license to operate. In the future, or from now on, we have to think that what we do with plastics, how we responsibly resolve the problem in the end, becomes a license to operate. We did a study together with the University of Lisbon, which itself is about 25 pages. So I only took 3-4 pages out of it. And the question was, how can bioplastics help to prevent biomass from going to landfill? What would that mean? So if we cannot prevent, we cannot reuse, then we need to think about recycling, and from our point of view, anaerobic digestion, so creating biogas out of that is a form of recycling, because we use Mother Nature's resources in the beginning, and only if that's not possible, we should incinerate and we should go into landfill. So the question was, how can PLA divert organic waste from landfill? And when you look at the life cycle analysis, which that is, then normally you look at not only the global warming potential, but also you look at other aspects. For this study, we only looked at global warming potential. We took several examples here. So we took 5 examples. We took a coffee cup, a yogurt cup, a coffee capsule, a tea bag, and a cucumber. And in Europe, all cucumbers are shrink wrapped. So you might say, why do they use the plastic for shrink wrapping? The reason is that it increases the shelf life by 3 to 4 days. And with that, it's actually reducing the waste. And what we have here is the water percentages before and the water percentage after use. And then we looked at from a CO2, also from a global warming aspect, what is the best option: incineration, landfill, composting, and anaerobic digestion. And I'm just showing the results for incineration and for anaerobic digestion, otherwise the report would be too long. So this is the results for incineration. What we can see is that if we don't have a lot of water in, which is the first 3, then with PLA, the LCA becomes positive, which means we generate energy out of it. Whereas with fossil fuel-based plastics, we actually need energy. But if you have a lot of water in it, then it doesn't make sense to incinerate. When we look at anaerobic digestion, so basically putting it together, the rule is the more biomass we have, the more energy we generate. It's actually very simple. It's just done scientifically now. So we can go to the next one. And here comes some thoughts of what we actually could do, or what we should do from a. And it's difficult to say this, to implement will not be so easy, but I think what we now have is that we throw everything together away in the garbage, and it goes on a big landfill site, and then we have rack pickers taking the things apart, and what we can recycle is not the smartest way, because we have a huge mass of waste where only the things that have value are picked out. And I have to congratulate India, because you're one of the nations which recycles most of the plastic, 60% I think, but 40% still stays there because there is no value in it to recycle it. So what we should do is we should basically split it in 3 streams. We should have a stream split at home with a clear mark which says this is recycling, this goes for recycling. And we have the rack pickers work in a factory taking the waste apart. So this would mean that you have the glass in there, you have the metal in there, you have the rubber in there, you have the different plastics there, and that can be separated. So the rack pickers don't need to bend their back and basically with this they can stand at an increased level of productivity because it's already pre-sorted. The next stream is all the biomass together with some bioplastics. That can go into anaerobic digestion, where we generate energy and where we generate, in the end, fertilizer. That can go back to the farm or back to the field. And the third one is, there will be some packagings which you cannot recycle. If I want something that has a shelf life of a month or 2 months or 3 months, I might be forced to use a multi-layer packaging which I cannot recycle. That needs to be incinerated. And in my simplistic mind, it's in the end the extended producer's responsibility to decide which one he wants to use, but society has to pay for it, which means he has to pay for it, he has to charge it to the consumer, and we have to build the facilities to do that. Otherwise, we never get rid of this waste in the end. PLA is compostable, industrially compostable. But if you throw it in nature, in Delhi where it's hot as 50 degrees, it's gone after a couple of weeks. If it's in the north of India where it's 10 degrees, it will still be there after 2 years. So it's an illusion to think we can continue to waste in the way we do now. It will not work that way. So that's already the end of my speech, and I remember one of my professors saying when we graduated that the engineers are the camels with which the lawyers and the managers ride through the desert of business. So I can only tell you, continue with your advance of creating startups, because that's the revenge of the technical people against the business people. That's the way to create the value for the technical people and become business people. And it's relatively easy as a technical person to become an entrepreneur and become a business person. The other way around, from a business person to learn the technology is much more difficult. I have an engineering degree myself. So with that, thank you very much for your attention. And if you have questions, I'm here.
Thank you, Mr. Stefan. Any questions? Please.
India, actually, how you are going to supply?
Yeah, we are importing it right now from Thailand. I mean, we have to factory in Thailand for one reason only. When we invested 10 years ago, and then we made the decisions 15 years ago, Thailand was the second biggest exporter of sugar. Actually, Brazil is the biggest producer and exporter of sugar. In Thailand at that time was number 2. India was the second biggest producer, but still imported sugar at that time. Now the situation has changed in India. Now India starts to export sugar as well. Now once I see that we have a market and this factory fills up, then I want to build a plant here. Once I see that because India has both. India has the raw material and India has the potential market. When you compare that with China, China has the potential market, but they don't have the raw material. They're a biomass deficient country in the end, India. China is a biomass deficient. India has a biomass surplus.
Okay, some more question. This PLA can process directly, or we have to add certain additives in this?
That really depends on what you want to do. The examples in the back there you see are either 100% PLA.
No, we are actually in the process of injection molding in blown film or thermoforming.
Okay. First of all, we have to understand, and I didn't include any technology, but I'm happy with Bala to come back and make a technical session out of this. The glass transition temperature, and I don't know who knows about glass transition temperature is below the glass transition temperature, the molecules are frozen. They cannot move. Above the glass transition temperature, the polymer becomes flexible. So the glass transition temperature of polypropylene is somewhere at minus 20 degrees. If you take a chair, polypropylene chair, which you can comfortably sit on, you do this in Siberia at minus 30 degrees, you sit on the floor. The chair is not taking the strain because the molecules don't have flexibility anymore. The glass transition temperature of PLA is at 55 to 60 degrees. So if you want to have something for a cold application, you get something transparent. You, in normal cases, can use your current equipment. That will work. Shrinkage is more or less the same than PET. If you want to have something, and you see the example which I showed before, which goes to 100, 120 degrees, it will not be transparent and it needs to be crystalline. With crystallinity, you make sure that the molecules are at the lowest state of energy. They are already arranged. So if you basically go over the glass transition temperature, they don't change the form anymore. And then we need a hot mold, and we have a different shrinkage. So then we have to look, but you can still use the same thermoforming line, but we have to see how we adjust the mold, for example, in thermoforming. In injection molding, in principle, you can use the same mold. Again, we need to look at the shrinkage, whether that's going to work or not.
No, because that PLA you are supplying. So my question is that can PLA directly can process PLA alone?
When we look at the examples here, thank you. This is 100% PLA.
Okay.
These cups, the biomass is 100% PLA.
Okay.
But there are some fillers in there.
Okay. What about the film processing?
Film processing, PLA is too stiff to make a film. If you want to make a plastic bag, actually we are helping BASF to sell their PBAT, which is a compostable material but not bio-based.
Yeah, we are looking for that
So
actually.
if you want that, then I give you the contact details, or Bala can give that as well, of BASF. They're making EcoVio, and you can blow this on an LLDPA line or an LDPA line. You can blow it with minor adjustments. That's working, not on an HDP line.
Oh, thank you.
Now, our Aarti is here, daughter of engineer Ratna Sabhabadi. She is expert in the field. Do you have any questions, madam?
Presentation, the part end of life of options that you were mentioning, have you ever gone through any field study in this? For example, your forecasts were really nice. I was just listening now. When you are saying that to collect the plastic PLA alone separately, and then the industry should go for take steps to make a composting process, and then so on.
Well,
Do you
there
have any-
is an industry norm for the industrial composting. So there are 3 compostings globally. Yeah? So that's industrial compostings, home composting, soil composting. PLA is industrially compostable. There is a norm where this can be tested. Yes, we have the approval. Yes, it's already done in Europe.
Okay.
So that's done.
Okay.
But PLA, for example, is not home compostable, which
Okay.
is done at 25 degrees. In home composting, to my knowledge, only starch and PHA works, but not all of the PHAs, because it's a family. PHPV, for example, is not working. PHA is working. PBAT to a certain extent is working. I'm not exactly sure there. Soil compostability, again, it depends on the test, what you do.
So only a certain group of applications only we can implement this plastic, or because if you are making these tumblers and cups, everything, usually our practices that we just throw away and go on.
Yeah.
So to collect each and every material from the environment and then taking it to an industrial composting, this is going to be a very tough job, right?
Yeah.
So that's what I was thinking of.
Well, you're absolutely right, and I'm not advocating bioplastics to continue littering. This is the wrong concept.
Yeah.
And if you want to use PHAs and starches, we can do that, but the problem is then we need to change completely the food supply chain, because the polymer doesn't know when it should degrade. And as long as we lose 30% of the food globally between the farmer and the consumer, we probably need more plastic and not less plastic to protect the food and reduce the loss there. If you use starch and PHAs, then that probably not work, because the plastic is degraded before it arrives at the consumer. And this
level.
is the same coin but with different side.
Yeah.
And that's the challenge. But I think the conception that we can use now bioplastics to continue littering, it's the wrong approach.
Yeah,
We
that's
need to take the plastic out of the waste. We need to start to separate.
Thank you.
I mean, if I would be the government, I would charge traditional plastics a fee. I would charge traditional plastic $1,000 per ton and use this money. I wouldn't ban it. I would use this money to build the end-of-life solution.
Thank you, Stefan. Now,
Any further question? Otherwise, I'm here later on, and I have a business card, so you can contact me.
thank you, sir. Thank you. I request Engineer Annamalai to to present a memento to our guest. Before going to networking, the important agenda. Sir?